Hi, this is Algebra 2, Lesson 29. We're going to talk about uniform motion problems where D1 plus D2 equals K. We're starting on page 131. So far, all of our uniform motion problems have dealt with equal distances. We've had distance 1 equals distance 2 when they started at the same place and went the same distance, or distance 1 equals distance 2 when they went there and back again. If distance 1 equals distance 2, then rate 1 times time 1 equals rate 2 times times 2, time 2, because rate times time equals distance. In this lesson, distance 1 plus distance 2 is going to equal a total distance. So their diagrams will look like this. We went one distance, and then we continued, and so their total distance will be, let's say, 460 miles. Okay? So this is distance 1 plus distance 2 equals 460 miles. Here we have this train went this way, and this train went this way, and they met in the middle, and their total distance is 460 miles. Or we have two trains that started in the middle and went separate ways, and after a certain amount of time, they are 460 miles apart. Okay? In either case, D1, distance 1 plus distance 2 equals some number. In this case, it's 460 miles. So, rate 1 time 1 plus rate 2 time 2 equals 460. Okay? The rest of the problems are going to be set up the same, but our rate and times are going to be added to each other. So here's our first example. Napoleon walked part of the 60 miles to the battle and rode on a caisson the rest of the way. He walked at 3 miles per hour and rode at 9 miles per hour. If the total time of his trip was 8 hours, for how long did he walk? Okay, once again, you do not have to draw the little diagrams, but if you have trouble setting these up and thinking through them, then give the diagrams a try. Okay? They're a tool for you to use. So for this one, we will do the diagram. So we're starting here. We're going to end at the battle. He's going to walk for part of the distance, and then he's going to ride a caisson for part of the distance. So we have the distance walked and the distance rode, and this all equals 60 miles. Okay? So the rate he walked times the time he walked plus the rate he rode times the time he rode equals 60. We know from the problem that the rate he walked was 3. The rate walked is 3 miles per hour, and the rate he rode was 9 miles per hour. The total time of his trip, so that's time walked plus time rode, equals 8 hours. And now we need to solve for how long he walked. Okay, since we need to know how long we walked, let's solve this one for how long he rode. Time rode is going to equal, it's going to be 8 minus the time he walked. Okay, so now we can substitute this and these into the problems, and then we can solve for time walked. So we'll have rate walked is 3 times time walked, we don't know that yet, plus the rate rode is 9 times the time rode, which is 8 minus time walked, equals 60. And now that the only variables in our problem are time walked, we can solve this for time walked. So we have 3 time walked plus, this is 72 minus 9 time walked equals 60. So this is negative 6 time walked plus 72 equals 60. Subtract 72 from both sides. And we have negative 6 time walked equals negative 12. Divide both sides by negative 6. The negatives cancel and the time walked is 2 hours. Okay? If we had started this, if we had gotten this far and then started this by solving for time walked here, we would have come out with the answer here of how long he rode. And of course, if he walked for 2 hours and the total trip was 8 hours, then the time he rode was 6 hours. So if we had solved here for time walked, which would have been 8 minus the time he rode, and substituted that up here, we would have ended up with time rode equals 6 hours, and then we could have solved for time walked. So either way works. Here's another one. Edward Longshanks and Queen Eleanor were 54 miles apart at dawn. Edward began the journey to the meeting place at 8 a.m. at 3 miles per hour. 2 hours later, the Queen set out to meet him. If they met at 4 p.m., how fast did the Queen travel? Okay, so Edward Longshanks, which just means long legs, is traveling this way. Queen Eleanor is traveling this way, and they are meeting somewhere in the middle. And when they started, they were 54 miles apart, which means that the distance of Edward times the distance of the Queen plus the distance of the Queen is going to equal 54 miles. So the distance of Edward plus the distance of the Queen equals 54. Therefore, the rate of Edward times the time of Edward plus the rate of the Queen times the time of the Queen also equals 54. Okay? Edward began the journey at 8 and they meet each other at 4. So Edward's time is going to be 8 until noon is 4 hours plus 4 more hours till the afternoon, so it's going to equal 8 hours. The Queen set out 2 hours later, so her time is only 6 hours. The rate of Edward is 3 miles per hour. And the rate of the Queen is what we're trying to find out. Okay? So we're going to plug all of these into this formula and solve for the rate of the Queen. The rate of Edward is 3. The time of Edward is 8. Plus the rate of the Queen is what we're trying to find out. Times the time of the Queen, which is 6, equals 54. 24 plus 6 times the rate of the Queen equals 54. Subtract 24 from both sides. 6 equals 30. Oops, 6 rate of the Queen. Divide 6 from both sides, and the rate of the Queen is 5 miles an hour. At noon, Rocket Man whizzed off towards Rocket Land. 1 hour later, Moonfa whizzed off in the opposite direction at a speed of 200 kilometers an hour, less than that of Rocket Man. If they were 11,800 kilometers apart at 5 p.m., how fast did they each travel? Okay, so Rocket Man is traveling in one direction. Moonfa is traveling in the opposite direction. When they're done, they're 11,800 kilometers apart. So they're starting from the same direction. Rocket Man goes this way, Moonfa goes this way, and now they're 11,800 miles apart. Oh, kilometers, sorry. All right? So their distances, the distance of Rocket Man plus the distance of Moonfa equals 11,800 kilometers. So we can say the rate of Rocket Man times the time of Rocket Man plus the rate of Moonfa times the time of Moonfa equals 11,800. Rocket Man left at noon, and we're stopping counting at 5 p.m. So the time of Rocket Man is 5 hours. Moonfa left 1 hour later than Rocket Man did, so his time is only 4 hours. And we know that the rate of Moonfa is 200 kilometers per hour less than that of Rocket Man. So we can say that Moonfa plus 200 equals the rate of Rocket Man, or we could say the rate of Rocket Man minus 200 equals the rate of Moonfa. Either way would be correct. Okay, now we can plug all of these into this formula and solve for the rate of Rocket Man and for the rate of Moonfa. In the end, we need to know both rates. So we have the rate of Rocket Man, which equals the rate of Moonfa plus 200, times the time of Rocket Man, which is 5, plus the rate of Moonfa times the time of Moonfa, which is 4 hours, equals 11,800. So we have 5, the rate of Moonfa's, plus 5 times 200 is 1,000, plus 4 times the rate of Moonfa equals 11,800. Now we have 9 times the rate of Moonfa plus 1,000 equals 11,800, minus 1,000 from both sides, and 9 times Rocket Man, or 9 times the rate of Moonfa equals 10,800. Now we can divide both sides by 9, and the rate of Moonfa equals 1,200 kilometers per hour. If the rate of Moonfa is 1,200 kilometers per hour, and the rate of Rocket Man is 200 miles per hour more than that, then the rate of Rocket Man equals 1,400 kilometers per hour. Okay? That is it for this lesson. Try your practice problems. Let me know if you have any questions. And that's it. Thanks.